For those of you that don't know me, I'm Catherine Woodthorpe. I'm the chair of the Bushfire and Natural Hazards CRC, and I'm delighted to be chairing this really important session at AFAC 19. It's a very poignant session for me. Before we start, of course, I'd like to acknowledge that we're meeting today on the lands of the Kulin Nation, and I'd like to pay my respects to all First Peoples who might be here today and those in the past as well. This is a really special session today as we pay our respects to the inaugural chair of the Bushfire and Natural Hazards CRC, Dr Laurie Hammond, and I would personally like to welcome Catherine Hammond, Laurie's wife, and some of her friends, and Rick Anstey, Laurie's longtime business partner and friend, who both join us today for this oration. So thank you for coming all this way. We really appreciate it. Laurie and I first met in about 2000, and over the last best part of 20 years, we sat on various government boards together and remained firm friends during that time. Mary's going to tell you a lot more about him, but from the CRC's perspective, Laurie was an incredibly important figure. He became the chair in July 2013 and served as the chair until he sadly passed away last year. During this time, he led the development of strategy and helped to build the reputation of the CRC for its utilisation-focused research agenda. His catchphrase, used from the very early days and often repeated, was, "Utilisation is everything," a phrase that became the way of doing business in the CRC. It's deep in our DNA. Laurie's leadership of the board and invaluable advice to management have ensured the success of this CRC, a point made clear in the independent review of the CRC by today's speaker, Prof Mary O'Kane. So I'm equally delighted to welcome today our speaker, Prof Mary O'Kane AC, a friend of both mine and Laurie's. I can't imagine anyone more appropriate to give this oration. As a sister chair of several CRCs, and a reviewer of the whole programme back a few years ago, as well as individual reviews like of our own CRC last year, she brings a unique understanding to the issues of CRCs. But her stellar career encompasses far more than just the Cooperative Research Centre programme. There are far too many to mention. We'd be here all afternoon if I went through her CV. But for some highlights, she's currently the chair of the Independent Planning Commission of New South Wales. As I pointed out to her, she likes the easy jobs. She's chair of the Aurora Energy Board, the Space Environment Management CRC, and the Institute of Marine and Antarctic Studies at the University of Tasmania. Until recently, she was the Chief Scientist and Engineer of New South Wales, and previously, if I remember rightly, the youngest and the first woman Vice-Chancellor in Australia at the University of Adelaide. She currently and in the past has sat on a large number of boards, including listed boards like FH Folding and those of CSIRO and the CRC Committee. So please join me in welcoming Mary O'Kane to the stage.
Thanks, Catherine, and thank you all for inviting me. And in speaking, I too would like to acknowledge the traditional owners of the land we're meeting on. It was a tremendous honour to be asked to give this oration, this inaugural and memorial oration to Laurie. And so when Richard Thornton rang me and asked me, I said yes immediately. Maybe I say yes a bit often, but this one was a definite. I was particularly thrilled too, not only that my dear friend Catherine Woodthorpe was chairing the CRC, that Richard Thornton, who is a friend and I've known more back into the 90s when we were both working in speech recognition, maybe the 80s, was involved, but I'm particularly honoured that Catherine Hammond is here. She and I just had a very brief conversation. We last saw each other probably almost 20 years ago in a yoga class in Adelaide. It's also wonderful that Rick Anstey's here, Laurie's partner in the business. Rick tells me he last saw me in 1984 when he got a nice letter from me after giving a speech at UTS. So, you know, it's Old Home Week, and there's a few others in the audience, but I'll close that bit of it down. But I do want to talk in Old Home Week a little bit about Laurie before I get into the meat of the speech. I suppose I first met Catherine and Laurie in 1977 in Jamaica. Laurie had inspired my eldest stepson, Jeff, in marine biology. And Jeff looked up to Laurie and often talked about him. So when we were going to Jamaica to go to a coral reef conference, which was in Florida, but had side trips to the Caribbean islands, we chose Jamaica. Those were the days when conferences were real conferences. And I met Laurie, and I think I met Catherine. She'll have to tell me, I just can't quite remember, but I do remember meeting Laurie, talking and being impressed with a range of things he told me about the University of the West Indies and various other things. I then watched his career. Particular things struck me, that what he did at the Victorian Institute of Marine Science here in Victoria, and that became quite one of the leading marine science institutes in Australia. I then saw him go to head, I think he was the last head of CSIR in New Zealand. I never quite know what the title was, but basically he oversaw the breakup of CSIR and the creation of the Crown Research Institutes. And I always thought Laurie underestimated what he did in that role. To me, the Crown Research Institutes are definitely the jewel in the crown of the New Zealand research system, and have worked really, some of them in particular, work extraordinarily well in terms of making the R&D system there glue together, and have had a very big impact on New Zealand industry, the high-tech end of it, particularly the milk industry. I then was involved in bringing him back to Australia, and I'm proud of this. I was on the board of the famous, and only those of you who are old enough will remember this, of the multifunction polis, which of course was headquartered in Adelaide and ultimately took its form in what became the northern campus of the University of South Australia. I even named the silly thing when we were talking about, we've got to give this project a name, the physical thing, and I said, well, it's going to be a high-tech suburb, and you always name a suburb after an explorer or something and a geographical feature. So I said, something like Mawson, very famous scientist in South Australia, as in Mawson, the Antarctic, lakes. Oh, somebody said, that's a good idea, and the next day the Premier announced it. So to this day, that campus is called Mawson Lakes. But we needed a CEO. We were really hitting rough water. And I said, well, there's this really bright bloke over in New Zealand, an Australian, and to boot a Queenslander, so I said he'd be good to get, and we got Laurie to come across, and he took the job. He was a brave man. When the multifunction polis phenomenon dissolved and it really just became the development, Laurie moved to the University of Adelaide, where I was at the time, and then Catherine's taken up the story. He moved much more into the venture capital world and on. So Laurie had a role as a very influential CEO in several places. He then, in the last 20 years or so, had a very influential role on a lot of boards and committees, including the tax concession, tax incentive, the R&D commercialisation boards of various kinds, and lots of them. And important players like Catherine herself worked with Laurie to achieve an awful lot about what characterises the system to this day. So to me, I thought that was the entry to what I wanted to talk about tonight. Laurie really did influence the system, but the other thing that always struck me about Laurie, and we talked 4 or 5 times a year by phone in various stuck issues that one of us ran into, and we'd think, I'll ring Laurie, or Laurie would think, I'll ring Mary. One of the things I found is that Laurie was very, very clever in not being stuck by issues that came up, but rather seeing how they could be used to the advantage of his clients or whoever was working. He knew how to use what was a less than desirable or less than perfect system, and he was very clever at doing that. And I thought, let's try and grab the essence of that and talk a bit about how you can use the R&D system of Australia to your advantage, make it work for you, even if it's a less than ideal system. Now, when Richard tells me I'm a better than usual responded to requests, I didn't realise this, but he asked me for a title, and I was travelling somewhere, and I gave this title for the thing. Later, I didn't really want to use the national bit, so really this talk is about best research organisation structures for solving hard and intractable problems, really your problems rather than necessarily national problems. But my focus here is on, if you've got a problem needing research and development, what help is available and how do you get it and how do you maximise it? And it doesn't matter if you're a government, a community or public sector agency, for example a fire agency, an industry sector, be it, I've talked about grains there, but it might be meat and livestock or something, it might be manufacturing, a group of companies with pre-competitive problems, a business, a research lab, whatever. How can you use the system to get your problem solved? So before we go on to looking at how you solve it, let's talk about this messy R&D system that I'm referring to. I think it's messy, others might think it's perfect, but I haven't heard many people think it's perfect. I think it's important for us to think about some of the things that caused it to have the shape and the form it has. And it's different from other national systems, but not completely different. And I've got some of the things down here. I haven't got everything. It's some of the ones that strike me as important, but you'd have a different list. And maybe, you know, in the discussion we can talk about other things on the list. But there are some really great things about our R&D system. And one of them was the far-sightedness of the Australian government in creating CSIROs so long ago. And also some of the concentration on not just there, but on agricultural R&D with the research and development corporations, the idea of a levy, an agricultural levy that was put into a pot to fund research in that particular area, whether it be cotton or pork or horticulture or grains or whatever. That and the great thing CSIRO did for a long time, and still does, of course, was something that was very clever. Of course we developed major universities, but most places were doing that. Not many people had a CSIRO, not many people had an ag and R&D thing around the world. We worry that we're poor at manufacturing. We still are. My driver to the airport this morning reminded me, however, we still produce milk crates. It's nice to know we have the milk crate economy still going, but overall manufacturing has been a challenge. We don't believe our firms really exploit new knowledge sufficiently. That worries us, and we feel as though that we could do more in that area. We know that medical research, however, is a vote winner, as is astronomy of all things, and therefore, as I'll talk in the next, to the next slide, you do tend to see a lot of maybe just money well worth spent, but have we got our proportions right? We also realise that it's important to attract top university staff, and a lot of R&D money is spent in that regard because of the complex issue where their research typically drives the university's rankings, which in turn helps attract foreign students, and despite the debate going on at the moment in the press, it is a major national export industry, or at least it's a major contributor to our exports. We certainly believe we're poor at commercialising R&D. That's something we beat ourselves up on and have been beating ourselves up on ever since I was in the workforce. And I'm sure it happened a long time before that, but it really got going in the 80s, 90s and over the last 20 years or so. We also worry a lot that we have a lot of expertise in our public sector research organisations, in CSIRO and ANSTO, in our universities, in AIMS, VIMS, etc., and we often wonder how we can tap into it more effectively. And then we have a thing that is in many countries, but is particularly strong in Australia, where we've come to develop a range of R&D funding systems where there's a belief that if you have skin in the game, you'll be more committed. So universities don't get the full funding from an Australian Research Council grant, they get part of the funding. They don't get funding for the salary of the main researcher, they get funding for research assistants and so on. And this leads to what universities, particularly in Britain, call the burden of matched funding. If there's some money on the table, it's very hard to say no, but if you've got to put more money in, you can end up putting an awful lot of money to projects that you wouldn't have prioritised, actually. So I want to consider those and just think what that's led us to. So, the first one. Our far-sighted concentration on new knowledge, of course, as I said, led to CSIRO and the ag R&D things. We're poor at manufacturing, so we're forever trying to get new manufacturing CRCs up and running. Many of our firms are not exploiting new knowledge. That's where something like the R&D tax incentive, and we're one of a group, not a gigantic group of countries, that's had a tax concession or a tax incentive and works it reasonably well, although if you looked at today's press, you'll see there's a lot of criticism of the Treasurer for cutting it. And I'm not sure it's something Laurie would have liked to have seen that cut as much as had. Medical research is certainly a vote winner, and as I said, have we got the funding levels right? The fact we need to attract top people to our universities leads to a whole range of schemes, including our Federation Fellow schemes, our ARC Centres of Excellence, and so on. Our commercialising R&D led to the CRC program, and Ralph Slatcher, when he was Chief Scientist of Australia, had that great vision that CRCs would bring together our knowledge-intensive organisations, our firms, would help us produce great PhD students and so on, and to a large extent that has worked really well. And the Bushfire and Natural Hazard CRC is a particularly great example. I could give a whole lecture, and I'm sure Catherine Woodthorpe would wish that I did, on the public sector oriented CRCs. They have been, I think, the greatest success of the lot. But there's things like the Linkage grants have been very successful in this regard too. We are, and then on the skin in the game, almost everything involving universities and firms has this phenomenon that they're not fully funded research things. And there's 62 or so. Somebody in the room might know how many Australian Category A grants there are on the Commonwealth Grants Register. That was a quick counting on my part down the list. Where they all have this incredibly complex structure of how much money you actually get and how much you have to contribute yourself. And I mention this because as I move into talking about how you get help out of the system, I keep coming back to the issue of motivation. And sometimes these various drivers of the systems drive some very strange motivations indeed. So, is our R&D landscape delivering for us as a nation? Well, one thing that's becoming increasingly clear, we were very, very good at innovation in the 1990s, and we really powered our economy along at that point with particularly absorbing ICT. But in the last 20 years or so, our productivity growth has stalled completely. And even though the economy overall is in reasonable shape, there's a real danger we'll start to tank at some point due to the productivity growth stagnation. And it's, even though we have a lot of structures in that R&D structure, in our education structure, in other things that I'll come to in a moment, our innovation inputs are actually quite good, but we're very weak, it seems, at converting them to innovation outputs. We're weak at using the very system we've constructed nationally for ourselves. We're weak at turning it to our economic advantage. And a sort of hard example of that is how we go on the various international innovation indices. There's various ones of those. There's a World Economic Forum one, and there's one that I'm involved in on the advisory board, the Global Innovation Index, that comes out of Cornell and INSEAD. And in that one, Australia came 22nd in 1919. Its input ranking, however, was much higher at 15, but its output ranking was 31. And what does that mean? Well, this is a real test of your eyesight in this auditorium. But basically, if you can probably see the three little white circles, the top one is the input, the second one is the output, and the one over to the far left is the overall index. The index consists of equal weighting of inputs and outputs, and the inputs are typically institutions such as the political environment, the regulatory environment and so on, human capital and research, R&D, infrastructure, market sophistication, business sophistication, and the outputs on the other side are creative outputs, knowledge outputs, technology outputs. And in this, it's an interesting way of thinking of an economy. So our inputs are moderately good, our outputs are not so good. And does that matter? Well, when you compare us to other nations, the thing you particularly note is that nations we typically compare ourselves to, in general terms, are up there running in the top 10 and we're nowhere to be seen and haven't been anywhere to be seen on that index for a very long time. So a little country like Switzerland has led for a while. The Nordics do well, the Swedes, the Finland, Denmark, you'll see they're all up there. Germany does well. For the first time ever, Israel got into the top 10. You would expect it to be up there. And the ones that come high up don't necessarily have the highest input scores. Often the output will be higher, not always. But they're very, very good at that conversion that we seem to be relatively weak at. Maybe things are too easy here. So, going back over that again, is our R&D system delivering for us? No, I don't think it's certainly not delivering as efficiently as we'd like it to be nationally, and that's something we worry about and is worried about at the federal government and the Productivity Commission level. But I think there's a real plus in it. Our very complex system, our very good innovation inputs, is an incredible opportunity for particular organisations, be they individual governments, be they individual firms, be they research labs, be they CRCs or whatever, to take advantage of the complex system that's there and all the opportunities with it to get help analysis, funding support and ultimately, hopefully, economic success. But I think to do that, to take advantage of it, you've got to know what you're doing. And this is where Laurie was so good. He helped people get great clarity about how to move through this landscape. And one of the things that I always thought Laurie emphasised, and I've emphasised for a long time, is the issue that if you've got a problem, you've got to know what that problem is. And so I always say that problem definition, problem specification is one of the most important first steps of going out. Before you seek R&D funding, before you seek partners, work out what you're on about. For me, I don't know where the emphasis on that issue for Laurie started. For me, it started in my own field of automatic speech recognition, working with DARPA in the US. Not for very long, but even when I came back to Australia, I did a lot of work where we connected in various ways to the DARPA system. And DARPA, of course, is the Defence Advanced Research Projects Agency of the US, the innovation engine room of the US Department of Defence. And there's nothing like the Cold War for having driven innovation in the US. You know, thank you, DARPA, for the microwave oven, thank you for the internet, and thank you for many, many other great inventions of modern times. And a lot of DARPA's success, and the model has been used in other countries, so it's no longer only in the US, although it's primarily in the US, but you do see it move to other fields, like there's now ARPA-E, which is a version of it in the energy space. But going back to what really struck me about DARPA, and I used to think it was overemphasised, but then I came over the years to think it was spot on, was that they were very good at specifying the problems that they wanted tackled. And they would specify a version of the problem that was difficult but not open-ended. So they didn't try and say, I was going to say go to the moon. Let me use an example from close to my own field, machine translation. They didn't say just translate everything. Rather, they said, let's take this corpus in this scientific field and let's translate it up to a specification level of, 99% or whatever. And so they took a version of the problem they wanted to solve and developed very tight performance metrics on it. They then chose several, this wasn't the only DARPA model, but this was a very important and main one. They then chose several teams to work on the problem they'd specified against the performance metrics and measured them frequently. It was often every 3 months or 6 months. Then at about the 3-year mark, they whittled it down to a small number of the top performers, the top teams that were doing best, and went to the end run. And if they didn't get their full solution, if they didn't get anybody getting the full solution out, they came back to the problem several years later. So machine translation was tried several times. The first version in about the late 60s thought they were going to try something easy like fairy tales. Well, actually fairy tales are really hard because when you're trying to translate the idea of a frog turning into a prince, the whole issue of the concepts there is very hard. They worked out over time it was better to tackle deep scientific problems or translation of scientific papers. It's a much easier space and so on. But they did it several times until in the early 2000s, they finally cracked it. And the day after, Google employed the top winning team, and that is what Google Translate is today, because the other thing is DARPA put the IP out there, and that was one of the big transformative things in the world. So the whole idea of specification, I think, is really important. You don't have to do it exactly the DARPA way, but you do need to know. And Australian organisations, some of them have done it well, and I particularly cite the agricultural R&D corporations. And in particular, I suppose the biggest one, the Grains Research and Development Corporation, about 25 to 30 years ago, started a process of really working through its boards and through a range of committees to really work out what were the problems in the grains industry in a pre-competitive sense, largely pre-competitive, sometimes regionally pre-competitive, you know, South Australia versus the northern wetter areas and so on, and absolutely define them before it looked to get a solution to them. In other words, it was trying to get the best value on the money that the farmers and the governments were putting into the corporations, but really trying to be transformative. And that led to all sorts of things, you know, whether it was the wheat, you know, the great wheat we produce here for pasta and so on. There are many, many examples. Another great one was AMIRA, the Australian Minerals Industry Research Association, which is no longer that. It's AMIRA Limited, an international company that actually is a broker in the mining industry, but particularly was set up by the big mining companies, but big and small actually, coming together and looking at pre-competitive research that would be groundbreaking. It works well to this day, although it works around the world finding particular solutions to miners. It does pre-competitive work, but it will also act as an introduction agency and is very good at helping people specify their problems. In the Office of the Chief Scientist and Engineer in New South Wales Government, we tried to be careful about specifying problems, and we did it on a range of issues. One that is well known in the fire world is the PFAS problem, and there we were particularly looking at Williamtown Air Base, how to actually get the PFAS contaminated water off the base and off the surrounding district. But we used it trying to specify how we were going to deal with getting the numbers of koalas in New South Wales up as part of the very important New South Wales koala strategy. Not many other states have a koala strategy, and ours is full of well-defined issues as to what are the problems about koalas. But mining in the Sydney catchment was another one. And every time we worked through things that I'll come to, mechanisms, to really know what we were trying to solve. Because one of the things that I learned early in government work was that often you were solving problems where nobody had really specified it, which led to upset all around the place. But you see it in companies. We've got some great companies in Australia that are great at specifying their problems. One is CSL, the blood company. Another one, probably less known, but just about to enter the ASX 300, is a listed space and defence company, EOS, Electro-Optic Systems, and is very, very good in this space. But also companies like BHP and Rio Tinto have been very good, particularly when they're investing in mega research projects, and I'll come back to that. I had a go at Malcolm Turnbull a while ago, and I haven't put the picture up here, but he was criticising Glyn Davis, the then Vice-Chancellor of Melbourne University, for not being willing to look at universities being much better in working on commercialisation. And I came back in the Australian Financial Review saying, I don't believe that's where they're good. I don't believe that's where they have great expertise. What universities are really good is at being problem solvers or problem definers. And this is a quote from myself, nothing like, you know, quoting yourself in a speech, that why should we turn to universities as major problem solvers? Well, because universities, because of their research expertise, and I didn't write it in here, because of the way they approach research expertise and are forever having to apply for funding, are good at posing and refining research problems and working together to ask and articulate what is the issue we're trying to deal with. They're also great connectors with strong international reach. So if you ask an academic, a good research academic, to solve a hard problem, if they don't know how, they'll tell you who will. And that's a great advantage. So how do you go about solving your problem with all of that background? You can do it by lots of ways, and again, there's a bit of a test of the eyesight here too. But some of the techniques I've seen that work really well include consulting an expert or several experts in parallel. In the Office of the Chief Scientist and Engineer on the hard problems like the coal seam gas inquiry, we would often bring experts in several fields together to come and talk to us in detailed workshops, and we'd say, this is the problem area we're trying to work on. We want to know what the core problems are. We want to know where there are aspects of this problem that are easy to solve. We want to know where they're hard, and where they're hard, what is the central core issue. Another place where I saw a version of this working was when I was chairing the Australian Centre for Renewable Energy, which was actually, it wasn't a centre, it was the precursor to ARENA, it was the renewable energy funding body of the Commonwealth. We wanted to know, because we were spending $15 million every time we funded a geothermal drill at base. I mean, it was 15 plus. So we thought it would be nice to know where the actual hot rocks are, as opposed to going fishing at $15 million a pop. So we asked NICTA to convene a workshop for us, now Data 61, of could we solve this problem? Could we build a 3D geothermal map? So they brought in people from Geoscience Australia, from many universities, from CSIRO, from many firms, particularly from the petroleum and geothermal firms, and looked at all the data sets that might be relevant. And this led to a project that ACRE then funded, in which we were able to get a 3D map of Australia and to know with much greater precision where the heat was. Matter of fact, we found that most of it was not at 5 kilometres as we'd initially thought. Most of it was closer to the 3.5 to 4 kilometre down territory, and we knew more precisely exactly where it was. Sometimes getting nearest neighbours to say who overseas might be able to help. Sometimes there won't be anyone in Australia, but you need to find out where, so you go to nearby fields and ask. Sometimes it's a matter of working with other similar groups, be they other CRCs, other firms, other government agencies, and working together to work out how to define problems. Sometimes it's a matter of looking at other pre-competitive partners. I do a lot of reviewing of research projects, research centres around the world, and I was very impressed in Norway early this year looking at their SFI centre scheme, which I've seen a bit in the past. But what particularly impressed me this year was to notice that those centres, unlike our own CRCs, do no commercialisation. What happens is the firms that are party to them get together at the start of every so many years and define what problems they work on, problems that will move that set of firms along in a maximal way. And then they all have access to the IP. Now, our CRCs often do versions of this, but here the commercialisation happens completely in the firms and the research happens in the SFI centres. Talking to intermediary groups, they often have mechanisms for defining problems. Choosing a problem-solving group, and there have been a spate of them have come online in the last 10 years or so, and particularly the last 5, and Innocentive is one of the famous ones that basically put your problem out there and ask the world to solve it as a competition. Using a specialist firm in your field, and this is where that firm EOS is very good. It stays very close to its defence and space customers. It knows their business for them, and when they have research problems that need specification, as it's a research-based firm, it can do that for them. And then just putting the problem out there sometimes works. Sometimes you can work too hard to define things, I've decided. So with the PFAS problem, for example, we contacted every research group in New South Wales we could think of, and around the country, didn't limit to New South Wales, but we particularly talked to the Centre of Excellence in sort of geoengineering at the University of Newcastle, because we thought they could help us maybe build a big structure around the PFAS as it went into the sea at Newcastle and could put down big walls. And that's what they thought they would do, and they were working with us on working out how to specify and how we were going to raise the funding for it, when one day the late Scott Sloan, who was the centre director, rang me and he said, look, he said, we've been thinking about your problem, my postdoc has come up with an idea. And he said, we found that hemp, or marijuana, is very good at soaking PFAS out of liquid. And so rather than just go out and plant marijuana on the Williamtown Air Base, we funded the development of the work and the patents around this, and this is now in use. And the Newcastle Herald, when we announced it all, picked it up as Red Zone's green light, because the area around the base is called the Red Zone, and of course the great plant involved was thought to be an important industry partner for them. So sometimes it's just a matter of actually, I think, telling people and letting them cogitate and solve your problem, not only define it. I also mentioned that it can be important to solve an easier version of the problem. And I'd particularly like to draw attention here to Rio Tinto's Mine of the Future that they built a few years ago jointly with the Centre of Excellence in Autonomous Systems, headquartered at the University of Sydney. There, the person who sort of oversaw that, Hugh Darrant-White, who's my successor as Chief Scientist and Engineer of New South Wales, points out that what they did was they didn't actually think of very brilliant ways to build the mine, they just automated a mine, which is no mean task and is certainly a highly productive, leads to great productivity gains. But now they're going back and doing the problem with much more way-out ways of doing the mining. So no longer just automating what they were doing, but thinking of new super clever ways of doing it. So sometimes it's easier to solve an easier version of the problem first. So moving to problem solving, you've got your problem defined, you know what you're going to do. How do you go about solving it in that complex landscape I spoke about? There are many groups that can help you. Some of them are the publicly funded research agencies, CSIRO, ANSTO, AIMS, and so on. Often university, especially major research groups, and how do you reach them? How do you reach CSIRO? It's often through a few phone calls to go in the university's case, through the Deputy Vice-Chancellor Researcher's Office, in CSIRO's case, through the relevant division, but be ready in this phase for a lot of phone calls, quite a few cups of coffee, and going out to meet people. CRCs typically are easier to contact. You contact them, they tend to be smaller, more coordinated, and to know whether they can do the work or not and which of their groups or where you might go. They do tend to be friendlier organisations. Similarly, the centres of excellence, which are typically headquartered in universities, they tend to be relatively easy to go to, and in both cases, CRCs and centre of excellence are in defined fields, which makes it much easier. The medical research institutes, like the Walter and Eliza Hall here or the Garvan in Sydney, again tend to have specialist areas and tend to be relatively straightforward to contact. And relatively easy to work with. I've spoken about the intermediary groups, AMIRA, GRDC, FRDC and so on. And again, they can be very good at helping you find potential partners. As a matter of fact, that's their job as intermediaries in lots of ways. I've spoken about the specialist research-oriented companies, whether it be in defence or in big pharma. Often they're the ones who really do a lot of the heavy lifting as the R&D partners to the biggies. And then I mentioned competition-style intermediaries, which I'll come to in a minute because it's something I don't think we use enough in Australia. Also, don't stick to Australia. Why stick to Australia? Often the funding from other countries can come home to Australia, so you might as well try overseas institutes, whether it be the Crown Research Institutes of New Zealand, the Fraunhofer in Germany, those FSI centres in Norway. There's sometimes restrictions on the funding, but often there's ways of getting a lot of the funding. And a lot of these agencies can reach through to big amounts of funding. If you have a well-specified problem and a well-structured arrangement with your partner, getting that funding can be relatively easy. And mixing and matching is what clever organisations do. There's a robustness in mixing and matching the different partners. I want to quickly talk about the competition style and crowdsourcing intermediaries because they've become really important. And the first one that was important, I'm going to forget the details of the Gold Corp Challenge, but basically it was a Canadian gold company that knew that in the reserves it had, or in the areas it had access to, that there was a lot of gold, but wasn't sure why. It's the Gold Corp Challenge that inspired my thoughts about NICTA and the heat map. And they wanted to know where it was, but they had various data sets. So they put that out in a structured challenge on the web and said to people, tell us where the gold is. And two firms together won the prize. One of them was a Queensland a Western Australian firm, even though the Goldcorp Challenge came out of Canada, and they won the prize. And the prize was pretty hefty. I forget exactly what it was, maybe $1 million. But it was nothing to what Goldcorp made out of finding the gold. So it was an example of what there became a rash of basically competition prizes. Now, a lot of you have heard of the X prizes, whether it's actually to, have a commercial space company or go into space, or you've heard of the Hero X challenges, which are like the Kickstarter of the X prizes. And often there's things like the big health system one that was finished about a year or so ago, where they're quite structured and well known internationally. And there's many of these big challenge prizes, often offered by government. The government of Scotland put out the Saltier Prize, which was for wave energy to certain specifications some years ago. I've mentioned Innocentive, a company that's been going for quite a long time and structures competitions for you. And we've got our own developed company that came out of here in Melbourne, Kaggle, which was a data competition company which has now gone to the US but can still be accessed. And again, you can use Kaggle particularly for data-intensive competitions. The New South Wales government was the proud first government to use Kaggle, and we used it to look at the M4 freeway. We were able to provide data for all the times of how long we could provide loads of data for travel on the M4, and our question was, what is the best time to travel on the M4, and what is the time elapsed if you do that travel? And we gave a brilliant prize of $10,000. We got several hundred people applying, and we got, not only did the winning group get their $10,000, but we bought the next 2 or 3 solutions. And it was of enormous value to Roads and Maritime Services in New South Wales. So there's plenty more specialist competitions out there that I'm not talking to, but they're well worth thinking about and often worth joining up with other funding schemes. So when you actually have worked out who your partner's likely to be, what your problem is, there's a range of things that need to be discussed, and I think this is a problem that we often talk about, and it's one, again, Laurie used to refer to, that we don't necessarily discuss all the things that it's important to get on the table early enough so that you can get your solution and things work with your partner. You need to know who is the group. Can that group really deliver for me, or were they just nice people to meet over coffee? Who precisely is involved? Who else is not involved that we should have? What happens if some key researcher becomes unavailable? Sometimes it turns on 1 or 2 key researchers. Is that a safe position? Do they have the capacity to do what is needed? What are the actual deliverables and what are the progress metrics? How do you know if you're tracking on to success? Do you have fail-fast mechanisms? And what do you do if things start to go pear-shaped? What's the arrangement? Is it a contract, a JV, a partnership? Is it an application for a grant, which is an implicit partnership or an implicit contract? What are the time frames? And what happens if we suddenly find we go faster, or, as more often happens, we're going slower? What's the cost and payment structures? Have we got that right so the incentives are right? What funding support schemes might we use? Well down the list, this one, and so it should be. But important because there's a lot of money out there. What are the advantages and disadvantages? What are the intellectual property arrangements? Who will own what at the end? Will we have students working on it? And if we're doing it in several different parts, how are we going to integrate it into a product, into a system, or whatever? Also, maybe it's impolite to talk about it, but you do need to think about your partner's motivations. Why is the partner working with you? Is it because you were nice over coffee, or is it actually something a bit more? And it's really important to understand this is where that issue of the burden of matched funding and some of the other quirks of the system can come in. And people can be very disappointed if things don't work as they will, but people will be acting in a highly rational manner. And it's really important to understand the motivations. So with that, you get pretty close to the end. You can draw it up into matrices of all sorts of kinds. This is a very incomplete version of it, what goes with what and whatever. The things like CSIRO tend to be very good on big national problems, like what's the ideal Australian diet, how do we fix the Murray-Darling. University centres of excellence tend to be brilliant at tackling really hard, intractable problems that are at the core of issues. CRCs are very, very good for bringing industry together and solving pre-competitive problems, and so on. Also, when you get through if you work successfully with the various R&D groups, there are bonuses. Typically and underrated, but very highly rated by the CRC program, which is good, are the graduates that we produce. Often, working on a problem, you've had a range of PhD students, maybe master's students, maybe undergraduates, honours students, but often the great thing is you've got well-trained people who know your work and are there, for hopefully you picking up into the workforce. It's a wonderful way to have people who really deeply understand your problem and know how to solve it. You have the relationship. Often the relationship of doing a successful bit of R&D between partners leads to things going on and on forever. I used to be very amused with ICI in Britain. Used to have a whole heap of Australian researchers would go to Britain to work in ICI every summer in the long university vacation. Not because they did particular work, but ICI knew they were really good, particularly physical chemists, and had a close relationship with them. When it had a hard, intractable problem, they and people from other countries around the world could be called on to solve it. And maybe you've got special purpose equipment or software or whatever. In many ways, the thing is you've got to utilise all of this. As Laurie would have said, utilisation is everything. And as Laurie would have wanted, he would have wanted us to use the system. He would never have expected the system to be perfect, and that I don't think it ever will be. And I don't think Australia's going to solve its innovation and productivity problem completely anytime soon. But we can do our bit by cleverly using the system to our advantage to solve our particular R&D problems. Thank you.